This is the video for section 5.6, and we're going to talk about the remainder and the factor theorem. So the first thing that we're going to talk about is called the remainder theorem. Okay, here's what it says in words. If a polynomial, and they're going to call it p of x, is divided by x minus r, the remainder is a constant p of r, and the dividend equals the quotient times the divisor plus the remainder. Okay, so here's an example. If I have x squared plus 6x plus 2, then this equals x minus 4 times x plus 10 plus my remainder of 42. Now here's the deal. We're going to use the remainder theorem to help us evaluate a polynomial. Okay, it says applying the remainder theorem using synthetic division, which we've done before, to evaluate a function is called synthetic substitution. It's a convenient way to find the value of a function, especially when the degree of the polynomial is greater than 2. So here's an example. Okay, they gave us this function, 3x to the fourth minus 2x cubed plus 5x plus 2, and we're supposed to find f of 4. So we know that finding f of 4 just means we're going to take 4 and plug it into all of our x's. Well, the thing is, this is a pretty easy problem if I can use a calculator. But if I have to plug 4 in and it's 4 to the fourth times 3 and then 4 to the third times 2, those are pretty big numbers, and I'm going to have to do some multiplying. So we can use what they call the remainder theorem as a shortcut to evaluate a polynomial. So here's how you use synthetic division to do that. I'm going to take what I'm supposed to evaluate. So I'm supposed to evaluate when x is 4. So 4 is going to go in my little box. And then I'm going to write down the coefficients, just like we were going to do when we were doing synthetic division. So I have my 3, I have my -2. And remember, when we're writing down our coefficients, we can't be missing any exponents. Okay, so do you see I have an x to the fourth, an x to the third, but I don't have an x squared. So I actually need to plug in a 0 for my x squared term. Then I have my 5, and then I have my 2. Okay, using synthetic division, I'm going to bring down my 3. 3 times 4 is 12. Add it up and I get 10. 10 times 4 is 40. Add it up and I get 40. 40 times 4 is what, 160? Add it up and I get 165. And then 165 times 4 is 660. Add it up and I get 662. So before we were dividing and we would write out our answer. We're actually evaluating f of 4 by using synthetic division. And the remainder theorem says whatever I get as my remainder is my answer when I plug 4 into all of these x's. Okay, so 662 is what I would get if I said 3 times 4 to the fourth minus 2 times 4 to the third plus 5 times 4 plus 2. If I put this in my calculator, I'm going to get 662. So it's just kind of a shortcut to evaluate the polynomials. You can either plug the 4 directly in, or use synthetic division and use the remainder theorem to get that same answer. So this is 662, or when I use the remainder theorem, 662 is my remainder, and that's what I would get if I plugged 4 in. Okay, so let's do another one. If f of x is 3x cubed minus 6x squared plus x equals 11, minus 11, find f of 3. I could take 3 and plug it into all my x's and get my answer. And if you want to do it that way, then that's fine. Okay? Or I could put 3 in my box and use synthetic division, the remainder theorem. So I'm going to write down my coefficients, 3, -6, 1, -11. Bring down my 3. 3 times 3 is 9. Add it up and I get 3. 3 times 3 is 9. Add it up and I get 10. 10 times 3 is 30. Add that up and I get what, 19? So 19 is my answer. And I could check that by saying 3 cubed, that's 27, minus 6 times 4, plus 3 minus 11. And then when I plug that into the calculator, and just to show you that we still get the same answer, I have 3 times 27 minus 6 times 4, which is 24, plus 3 minus 11. Okay? Oops, 3 times 27 minus 24. I didn't get the same answer. What did I do wrong? The answer should be 19. So 3 times 3 is 9, 9 times 3 is 27, 27, 4, 3, 11. Do you see where I made my mistake? I'm looking. Hang on a second. Okay, if you see where I made my mistake, then let me know. 3x to the third minus 6x squared plus x minus 11. 3 times 3 is 9, 9 times 3 is 27. I don't see it. Okay, so if you find it, see where I made my mistake. 19 is my correct answer, but I should get the same answer when I plug it into this. Okay. Example 3, the number of college students from the U.S. who study abroad can be modeled by the function, and it gives you this function, where x is the number of years since 1993, and s of x is the number of students in thousands. How many U.S. students studied abroad in 2011? So they want to know, when I plug in 2011 in all these x's, what am I going to get? So let's use the remainder theorem to get our answer. Okay. Now here's the deal. What number am I going to put in my box? Okay. When I do this problem, it's the number of years since 1993. So in my box, I'm not going to put 2011. I'm going to put how many years apart 2011 is from 1993. So 2011 minus 1993 is 18 years. So 18 is going to go on my box. Okay, so now I'm going to write down the coefficients. I have 0.02, negative 0.52, 4.03, 0.009, and 77.54. I'm using synthetic division, and I'm going to use the remainder theorem to evaluate this polynomial when my years are 18. So 0.02. 0.02 times 18 is 0.36. So negative 0.52 plus a positive 30.36 is negative 0.16. Negative 0.16 times 18 is negative 2.88. 4.03 and a negative 2.88. Let's see, 4.03 minus 2.88 is 1.15. When I add that to 0.009, I get 1.15. That goes there. Sorry. So when I add those up, I get 1.15. 1.15 times 18 is 20.7. When I add these up, plus 0.009, 20.7 plus 0.009, I get 20.709, and that times 18, 372.762, and when I add those together, I get 450.302. Okay, so my remainder is my answer. So it's 450 and it says in thousands. So about 450,000 students. Okay, you might double check my numbers because my numbers are off just a little bit. If I added or subtracted wrong, you might fix it as you go along. Okay, example 4. Well, so factors of polynomials. So this next factor theorem, so that first one was called the remainder theorem. This one's called the factor theorem. Basically, they're saying if I do synthetic division and I get 0 as the remainder, then I know that that factor will go evenly. Okay, so it is a factor of that polynomial. Okay, just like I know that 3 will go into 15 evenly, so 3 is a factor of 15. Okay, but if I said 2 into 15, it won't go evenly, so 2 is not a factor of 15. So when we use synthetic division, if I have 0 as a remainder, I know that that was a factor of that polynomial. And it says right here, when you divide a polynomial by one of its binomial factors, the quotient is called a depressed polynomial. A depressed polynomial has a degree that is 1 less than the original polynomial. And that's what we learned whenever we were doing synthetic division. So it says the binomial x minus r is a factor of the polynomial if and only if its remainder is 0. And it says the factor theorem can be used to determine whether a binomial is a factor of a polynomial. All right, so let's use the factor theorem to do example 4. Determine whether x minus 5 is a factor of this, then find the remaining factors of the polynomial. So I'm going to use synthetic division. Remember, if I have x minus 5, I always use the opposite sign that goes in my box. My leading coefficients are 1, -7, 7, and 15. And I'm going to bring down my 1. So 1 times 5 is 5. Add them up, and I get -2. Okay, -2 times 5 is -10. Add it up, and I get -3. -3 times 5 is -15. Add it up, and I get 0. Remember, my last term is my remainder. So since I have a remainder of 0, that means that x minus 5 is a factor. And then when it says then find the remaining factors, so I need to write the answer that I would have for this, okay? So first of all, I know that x minus 5 worked, all right? Now I'm going to write down my answer. Since it started off as x to the third, this one would start off as x squared minus 2x minus 3. And when it says find the remaining factors, they want us to factor that last part. They want us to factor our answers. So I still have x minus 5. Over here, I'm factoring this trinomial. I know it's going to be x and x. I know my signs are different, so one's plus and one's minus. I need factors of 3 that when I subtract them, I get 2. So it has to be 3 and 1. My 3 goes with the minus. My 1 goes with this. And then those won't factor anymore, so that is my answer. Okay? You guys are going to be doing page 355, which is section 5-6. And we're going to do let's see here, 1 through 27 odd on page 355.